I'm in behalf of Florent Gravin, that is the main R&D person in charge of geospatial divisions too. And well, he was planning to come, but it was difficult for him. Just then I part of the team and then showing what we are doing in Camp2Camp. Then some techniques on geospatial, and we want to share that this space for because the FOSS4G is just for that collaboration, just to share what we are doing and what we envision as the things that we can be done with geospatial and LLMs, or LLMs and in the context of geospatial. Then what you have is AI is just wrapping all the things that includes machine learning, then you have deep learning and generative AI itself. Every time that you are going deep on this, you are specifying more things about what you want to do with the AI in general, okay? Okay, what we can do with or what the LLMs models can do with for us in geospatial. As I mentioned, AI in general, it's used in even more in geospatial for Earth observation from a long time ago. It's not new. The kind of things when I finished my degree, it was a genetic algorithm. So it's part of the AI, but it's not used in the context of even I could say that it was not used even in the context of Earth observation. For that, we have another kind of methods. In context of LLM, that is a brand new thing that we have, and it's just doing a lot of noise, is that we can, it's very friendly with the users, and that's the amazing thing, and we can ask the bot, essentially, or the model, just to bring information and create that content that we want to understand. So, some examples. Let me see if we can go with this one. We prepared a video about, I don't know if it's going because of the brightness of this, but you will see in this video that we are writing for queries, small things like building in morgues, that's a city in Switzerland, or parks in Geneva, and then you get something that it's quite simple. But then you can start writing in another way, in a more natural way. And that's the LLM what allows you to do in context of the user. You can write in a simple, anyone can write in a simple way, and then you can get information shown in the map. So that's the kind of stuff that will allow us to do LLM. We will mention which are the things that we believe that is going to be quite simple or a straightforward application of the LLM models. And also, but probably there will be a lot of more things that we can realize with the practice about what we can do. Just to simplify, this is 20 minutes, 30, we cannot do much more than that. So it's, this is the pyramid of complexity. What implies this? This is at the bottom we have what we expect as normal users to use, chat with someone. We know how to do that. So it's a bot in this case, but we get is content based on what we are trying to do. Simple, okay? Then there are some other aspects that allow you to do more complex things. One is the prompt engineering. Probably some of you already listened or, heard about writing the questions in a way that allow you to find information. Exactly what you did when you learned to look in Google. If you started just searching for something, with the practice, you realize that if you write in a way, then you get the best results. This is the same thing. The prompt engineering is about that, mainly. Asking in a way that is more understandable by the bots or the models. Then you have the retrieval augmented generation. It's like allowing the agents or the different machines or models just to work alone, just to retrieve some information based on what we are asking, okay? And the fine-tuned models. That's the simple one, and when you move up, it's much more complex. On the other side, what you have is data integration. At the bottom, you can have world-hosted data. That is something that usually we expect that is normalized in some way. Then you have custom data as something that is going to be from your own expertise or your own way to define it. The optimized one and the information that you need for the train or training the models. That's something that the harder part on this is the trained data, because you need to validate that is something that it will be useful. So that trained information is the information that will allow you to respond or to get better answers on what you are asking for. A prompt. The prompt definition is that instead of asking in the way that you want, you will write something in this way. So you are defining the mood of how it could be also included on the prompt, how to answer. You can say the bot just write me as if I am a kid, or answer the question as if I am a kid. In this case, what we have is the user query was this one, and we are instructing to say that we are a geospatial expert, and we have to include information from overpass. Well, it's not going to be clear maybe, but the limitations on the diagram, but what you are doing is allowing to rewrite the question and then to decode it and back to the user. That's the prompt engineering. Limitations is that you can reply based on the data, and that has been trained, and you can answer with your own data. So for that, you have different, the next step in complexity, that is the retrieval augmented generation, or RAG. In the RAG, the technique, what it's doing is just enhancing that, allowing you to include different models and also agents just to work together and get a better answer, okay? Structurally, what you have is a kind of prompt that will be sent to the LLMs, but at the same time, you can answer and get back feedback. And the main thing in the process is that you are getting information from different sources and then get back feedback to the vector source and try to compare that and get better answers based on that. Just an example of that. The benefit is that I think it's the next slide, you can use LLMs with your own data, okay? You can use data that is highly demanded or that is used, really, and improve. This is something normal that you notice on ChatGPT, that is, you have a lot of hallucinations when you get for a question that is very open. So with the attempt of using RAG, you reduce that hallucinations or that way that the ChatGPT is answering for what you are looking for, okay? The problem with that, well, and the fine-tuning, that is the latest model that, or the high complexity that you need for a better LLM tuning, or in particular, what you need is, the problem with that is that it demands a lot of skill and knowledge about what you are doing, okay? And it's not only in the technical side. Probably it's also in the expertise on the field that you are working, because you need to train that, and to train information for geological aspect or urban urbanization or for deforestation is not the same. Okay, so that's the top of the complexity in the pyramid. So something maybe important is that fine-tuning, it's only the last solution, okay? It will take a lot of time, and probably it's more a concern that we can rely, and I like to link talks when I came here to the FOS, that remembers the initial talk that was done by on yesterday in the morning about how academic world can work with the companies or the business world. Why? Because this kind of stuff that is fine-tuning models it demands a lot of work, and it will be possible just to take years just to get a good result. What we can do at the end, then, we essentially notice that the straightforward things that we can use for LLM, it's trying to improve the search experience, okay? Use that in a conversational UI, because we can interact quickly and briefly with the model and get the results, and then re-ask if we want to get it a different result that is not what you expect. And to do some stuff that is not the usual work that people enjoy, like metadata. Because based on that, you can, on small things, you can enrich your data, maybe your metadata definition, so you can get a better approach of what is happening with the information, or what represents the data that you have there. Some cases, improving the search includes some generation of synonyms, reformulation, semantic search, or ranking things. For semantic search, you are looking for something that is not a keyword. You are looking for semantic. What I can say in a word is different in terms, but it could be the same thing that we are thinking with another person. So the case is that I'm not going to, this is about how we check the similarity search that is based on the key and on an index that is a similarity, but I want to show you this. This is a search and a comparison between the lexical and the semantic. Look on the results. That one is basically looking for the exact match of the results. And this one is looking based on a search that is based on the semantic of the search. That's the difference between doing the semantic and the lexical search, essentially. This is much more rich and allows to avoid the complexity of defining the right or the set of keywords that represent your data set, okay? Essentially what you will have is that, let me see. The same approach in this video. It's trying to show you, you will see here, maybe it's not clear, but you can chat or define questions or things that you would like to see or to check or review, and then the bot is getting that and transforming into actions in a map, okay? I maybe jumping some slides on this, but essentially the LLM models will find that is the straightforward action that we can use them is for the interaction with the users, okay? You don't need to be an expert on using tools that are really complex. All of us know that geospatial itself involves a lot of things, not only the cartography, also how to handle data and how to manage that. So this brings new things on the conversation that a user can do based on the map. Yesterday, again, part of the talk was about images are not showing text. Yeah, we need to interpret that text, that images. It's the difference with reading. When you read, you know what you're reading. But when you get a map or an image, you need to interpret what is happening. So this is the kind of stuff that you can use for LLM. Just for, the minor thing is just allowing you to interpret the things. AA as an assistant for that. Improvements for the search. You can do with the RAG, you can also set logic around that. So you can say, I want to do this in this kind of area, and define the boundary of the area based on something that I don't know to specifically define. It will look for by the agent and then introduce it in the rest of the process. Conversational is quite simple or similar to what we talk. The difference with this is that we are providing a chatbot for that. And there is an example here. Maybe it's a little longer. But instead of For the example, probably if you get the slides, you will be able to look it on that. But what is happening here is that it's asking for specific things like in a conversation. In this case, the conversation is about, hey, I want to know if there are military areas in Switzerland. Yes, these ones. But I want to see where they are. And then the bot itself is saying that not all of them are clearly exposed to public because they are secret or based on confidential information. So that kind of stuff is the one that you can provide. Certainly on the conversational UI, you have more information or not, and then that conversation is with the bot, not specifically with someone answering that. For metadata, some of the things that we found interesting is that we can enrich the process, reduce the complexity of filling this information, and our speech about that is that instead of people spending time on writing the metadata in a right way, that is something that you can use, it's maybe more convenient just to allow a bot to be trained and to be learning how to enrich metadata based on small things or small definitions. In the case of Ticino, what we did was just from the original, it's not going to be clear here, but from the original abstract that is just one line, based on more information that are quite similar, layers from the federal office in Switzerland, you can enrich the rest of the things and define keywords under all of that. Limitations? Yeah, 2 minutes. Limitations. Obviously, this, maybe it's something that we want to share is that it's not easy, okay? Depending on what you are doing, you are going to pay. You are going to pay on the setup for having your own machines running this, or you are going to pay for the service because OpenAI, if you want to use it, that is the company behind ChatGPT, will ask you for money for your account. And it's not so easy to implement it. There are some aspects that, like readability with hallucinations or sensitivity on the data. There are also discussions about ethics, but those are the main limitations that we will have. Conclusions is that historically it was used, it's not new. The new thing is that the large language models can help you with some stuff. That stuff essentially is improvement related to facilitate integration and communication with the users. And well, we are still, we will continue working on this. The company has decided to move on this direction too. Almost 1-2 years just investing on RRD and working on this kind of stuff. Thank you. Sorry for the inconvenience at the beginning, but we are done. And just thank you so much for it.